An AI just passed a critical test that almost everyone said was years away, truly understanding the physical world. This isn't about chatbot essays. This is about real robots, manipulating real objects, and fundamentally changing industries from manufacturing to healthcare. A new evaluation reveals one frontier model achieved an 82% success rate on complex physics problems. We'll break down these secret benchmarks, reveal which models truly lead this new physical AI race, and what the 3 crucial numbers buried in the data actually mean for your future. For years, large language models were brilliant at words, but clumsy in reality. They could write poems but couldn't tell you if a stack block tower would fall. This fundamental gap kept truly intelligent robots firmly in science fiction. But a groundbreaking new evaluation from Julia Hub just changed everything. Researchers put leading frontier models, including proxies for future GPT-5.6 and Claude Fable 5, through a rigorous gauntlet of 20 different tasks designed to test their physical reasoning. These weren't hypothetical questions, they involved robot programming challenges, material science predictions, and advanced physics problems. The core question, can AI actually understand the physical laws governing our world, not just describe them? The results are a stark reality check for some, and a massive validation for others. The evaluation pitted models like GPT-4, Claude 3 Opus, Gemini 1.5 Pro, and the powerful Llama 3 400B against each other in categories like robot programming, physics problem solving, and materials science. What emerged was a clear hierarchy. According to the study, Llama 3 400B, a model often seen as a benchmark for future open-source giants, dominated the physics problem-solving tasks, achieving an impressive 82% success rate. To put that in perspective, that's better than many human experts would score without specialized tools. Gemini 1.5 Pro also showed remarkable capability, especially in creative robot programming scenarios, where it significantly outperformed its peers. However, not all frontier models were created equal. Claude 3 Opus, representing the cutting edge of Anthropic's current capabilities, lagged behind in many of these critical physical reasoning benchmarks, particularly in physics where it only managed a 60% success rate. The data suggests that while some models are making monumental leaps, others are hitting unexpected walls when it comes to the real world. This 22-point gap between the top performers isn't just a number, it's a chasm in practical application for robotics. Here's the critical twist everyone missed: it wasn't the usual closed-source giants dominating every category. While OpenAI's GPT-4 and Anthropic's Claude 3 Opus certainly performed well in some areas, the open-source aligned Llama 3 400B often outperformed them in core physical reasoning. This means the future of AI that truly understands and manipulates the physical world might not be locked behind multi-billion-dollar labs. It suggests a more democratized future for physical AI development, where innovation can come from unexpected places. However, the study also revealed a sobering truth: even the best models still failed on 18% of tasks, highlighting a persistent gap in true, generalized physical common sense. They might solve complex equations, but still miss obvious physical constraints. This 18% failure rate is the hidden hurdle that still needs to be overcome for truly autonomous physical AI. This isn't just a set of benchmark scores, it's a seismic shift. If frontier LLMs can genuinely grasp the intricate laws of physics with 82% accuracy, then truly autonomous, versatile robots are closer than we think. This breakthrough hints at a future where factory floors, surgical suites, and even our homes could be transformed by physically intelligent AI. The rivalry between these models isn't just for bragging rights, it's a race to unlock the next generation of automation. The implications are profound, touching everything from supply chains to healthcare, potentially impacting billions in global economy. The ability of AI to reason about the physical world is the missing link, and it's finally starting to click into place. The 3 numbers that matter: 82% accuracy, a 22-point performance gap, and the 18% remaining challenge. These define the new frontier. Next, we'll dive into the surprising ethical questions that arise when AI starts truly understanding and manipulating the physical world.